Hi guys, welcome to the September edition of the Dublin G2 meeting. We don't. This time we have a little bit more time than usual. Actually, we're I won't say content light this time, but we don't have as much content as I was referring to my own content. So for anybody who hasn't been here before, although most of the faces are reasonably familiar, welcome. There's three of us involved in running the G2, myself, Brian, Owen, couldn't make it here today. Sergio and Jean do all the hard work, actually. We just turn up. So we've got, I didn't get a chance to do a slide today with the agenda. There's three talks on the agenda today. First up, Kenneth is going to talk about the data storage on App Engine and, interestingly, the changes to pricing, which I think some people will be quite interested in. I'll take a few questions after that. Towing the party line there, and we're going to have a break after that, and then we've got a couple of talks which largely came out of, well, not largely, which came out of the HTML5 hackathon we had in early August. So Pavel is going to talk about some WebSockets-based stuff, and I'm going to talk about our interesting journey on playing storage and the file system API. And then I think is Brendan Wise here? No, he wanted to talk about an event on AOL this weekend, which is a JavaScript focus. Does anybody else? Maybe you want to talk about it? Yeah, so Pavel mentioned that in the notices then. And then we'll just go to the schoolhouse probably for a pint if anybody is up for it. I guess Kenneth.
Brian mentioned there's a few hyperlinks in the audience here, so I do have a bit of code later on, but I actually just typed it directly into the slide, so. I'm stuck to the podium, am I? Am I going to be over my Which one is there? If you prefer, there's also yeah, that'd be fine. All right, how's that? Okay, so App Engine pricing model changes. Is anybody here aware of the changes that are going on in the App Engine pricing model? Has anybody sort of been keeping track of sort of that sort of interesting scenario? Yeah, there's been a lot of stuff up in the forums about that. They first announced it back in March or May, I think it was, and there was a lot of hemming and hawing back at that time. And then at the end of August, they actually did what's called side-by-side billing, where you could actually see what the price changes were going to, how they're going to affect you. And a lot of people fell off the floor, including myself. Without further ado, the way App Engine works right now is that when you upload your application to App Engine, you have a free tier and you have a paid tier. And the resources that you're charged for in App Engine is the CPU usage, which is fairly easy to understand. Every time you make a particular call to your application, that counts a certain number of milliseconds against your CPU usage. So you get 6.5 hours free every single day. Nothing rolls over. So bandwidth, you get 1 gig in, 1 gig out for free. And then storage costs, you get 1 gig for free. And then I think it's about 8 cents a month or something like that. I can't remember exactly what it charges. But anyhow, under the new model, Google's changed things fairly significantly in terms of how the CPU usage is charged. So what we believe Google has discovered, and they've said this in various blog posts, is that most web applications are I/O bound. So when you make a call to a web server, it's waiting for the database, it's waiting for the disk, it's waiting for another URL call or something like that. And so that means the application becomes memory bound. So you're using a certain amount of resident memory for your particular web server instance. And that kind of cost was not being captured in the old pricing model. So if you have an application with, say, 20 instances running, using up 2 gigabytes of memory, and they're mostly just I/O bound. So you're doing URL fetches or something like that to another server, to a Twitter or Facebook or something like that. You can almost run that for free in the old pricing model, but the cost to Google were significantly higher for that. So what Google is saying that we're going to change these pricing models, and hopefully we'll leave beta, because Google App Engine is currently beta, and we don't want it to go the way of some other Google products that we know and love, or not. Preview beta, yeah. There's actually a labs thing in Gmail where you can put the beta back, so some people get nostalgic for that kind of thing. So from November the 1st, it was originally going to be from, I think, probably today, they were going to change the pricing, and they backed down on that one. But from November the 1st then, Google's changing the model so it's instance-based. So if you're familiar with how Amazon charges for their EC2 instances, it's the same idea. So essentially, every single minute that your instance is running, you're charged money on that. So if you have 10 instances running for an hour, that's 10 instance hours. So when they first announced it was 24 instance hours free, which basically meant you could run one instance constantly across the day. They've upped that to 28 instance hours for free, so you can have a couple of spikes in there. If you're writing the application in Python, then each instance can serve one web request at a time, which is probably not the same as an Amazon instance. Probably about an order of magnitude or two difference. If you're running Java, there's multi-threading in Java already today, but I wouldn't know anything about that. And then the other big change is data store access is now something you get charged for. So prior to that, the data store access was rolled into the CPU usage, and that was all part of the charge. Now you get charged for data store access separately, which actually is almost one of the more significant things, especially if you have an application that does a lot of I/O on the data store. There's also a new minimum spend of $9 a month. So it was when it was first introduced, that was going to be $9 plus usage. Now it's usage up to $9, and then you get charged above that. So that's kind of a nice little change they made too. The other charges then for the bandwidth and for the things like channel API and the storage are remaining the same. Thinking about the HR and the master-slave differences that are separate to this. So Google has publicly stated that charges are going to go up for the average application of 2 times to 5 times. So from some people, that's a pretty big sticker shock. And there was a whole bunch of stuff on the forums about people, who were basically running, a couple cents a day, and it suddenly went up to $5 or $10 a day. So that was pretty bad. And like I was saying to Brian, there was one guy on the forum who was actually spending $100,000 a year, and it was going up to like $1 million a year or something insane. So yeah, it takes all types. I don't know what the hell he was doing, but he had screenshots, so he wasn't just making it up. Okay, so I was just describing what instance is then. The instance it's a similar idea to an EC2 instance, except it's not a proper virtual machine. So there's no operating system on top of it per se. It's a lot less powerful than an EC2 instance, so it can serve a lot less. An EC2 instance is, if you're doing something fairly lightweight, you could probably get, certainly several hundred requests simultaneously going on an Apache server on an EC2 instance. But with the Python ones, you can only do one at a time, which is expected to change sometime in November or December. They're also far easier to manage. So an Amazon EC2 instance, you have to patch it, you have to run Apache on it, you have to get all your services running, all your daemons running, everything like that. Whereas the Google instances are just, when you write to the Google platform API, Google spins them up, spins them down. That's all very, very easy to manage. One of the big controversies about the instances is the Google scheduler, which determines how your instances spin up and how they spin down. And Google's been tweaking the living daylights out of that over the past number of weeks, certainly. And you can see sometimes they make changes to it, and the number of instances goes up and the number of instances goes down. Spinning up an instance, depending upon what you're doing, can take about 500 milliseconds to maybe 10 or 20 seconds, I've heard, for some Java instances. So what you want to do is you want to keep idle instances running around, and the idle instances allow you to allow your requests to be serviced much quicker. So you can control to Google how many idle instances you have running on that, and Google kind of makes an intelligent guess about how busy your application's been. So it may have 2 or 3 idle instances. I've seen it going 4 or 5 idle instances at the same time. There's a limited set of controls over how instances are started, how idle instances are controlled, and how long Google lets your requests stay in the request queue before it spins up a new instance. And that's certainly, I think, probably one of the areas around the instances that's been the most controversial. Most importantly, there's no way to hard cap the number. So if you're running a small little website that, maybe every once in a while it gets a spike or something like that, or if you have a page that does a lot of AJAX requests and they all come in simultaneously, Google will spin up those instances, and they won't spin them down probably as quickly as you'd like. So you can actually, with the 28 free instance hours, you could easily imagine a scenario where sometime around midnight, you run out of quota and your application starts getting denied. So it would be actually nice if Google put a hard cap on the numbers. So, maybe during a busy period, you might get some long requests or you might get some timeouts. But at least, at the end of the day, you're not going to be just giving everybody, I think it's a 503 error. There was a great blog post, actually, if you look on the groups, about somebody who was trying to control their instances. I just thought I'd grab some of the stuff from his blog. Essentially, what people are doing, instead of hard capping their instances, these are the controls that you have. So you can control the maximum number of idle instances and the latency. So how long you're willing to let your requests wait before Google spins up a new instance. And there was some theory about setting the idle instances to 1, which is the lowest number, and setting the pending latency to 15 seconds, which is the maximum number, might only set you to 1 instance. It doesn't quite work that way. But you can actually see here on his instance count. Up here, he's running 10 instances. You can see it bouncing up. It peaks at 25 instances. And then the orange line at the bottom then is the active instances, which has always struck me as fairly surprised that it's quite low down. If you imagine an instance was serving you maximum time, it should be a little higher. But anyhow, you can see the drop there down to about 5, 6 instances when he did that control on it. So again, if you look at that right there, after the drop there, it's a 6-hour window. He's using 5 instances, so that's going to be 30 instance hours, which is going to be quite expensive over a 6-hour period. You can also do things like reserving instances, which makes them cheaper. It's kind of the same way Amazon has an equivalent thing that you can do with that. There's also Google's offering half-price instances until the end of the year, I think, to compensate for the fact that Python doesn't have multi-threading. But really, the biggest thing you can do is just making your application faster. So, if your application has latency of 50 milliseconds, you're going to be able to do 20, how many is that big? 20 per second requests at its peak. Whereas if your application has a 500 millisecond latency on its requests, you'll be able to do 2 per second per instance. So that's really where people get hammered if the instances are quite slow. So, all right, I'm motoring through this. Any questions at this point? Yeah? Okay. The other thing then is the data store costs. So if you go and look at that blog I mentioned before, he was actually had a problem where his data store costs, which previously weren't really charged by Google, went up to like $50 a day. And he was doing some pretty interesting things with it and managed to drive it down again. But the general gist of the data store costs is write operations, read operations, and small operations are all charged at different bands on that one. And it's fairly opaque as to how Google is charging for that until you actually get your bill delivered the following day now. So in write operations, if you put a single instance into the data store and it has 5 properties that are indexed, I believe, now I'm not 100% certain of this, but I'm about 90% certain, that will count as 6 writes to your chargeable requests. So you've got to try and reduce the number of indexes. And also the indexes drive up your overall storage cost. So it's a good idea to do that. Now, if you do put indexed false on a particular property, you will not be able to retrieve it by that property until you remove the index false and rewrite all the entities that were written with index false. So it's something you don't want to do lightly. The other thing then is the small operations are very cheap. So if you actually do something, rather than doing a query on a particular entity, if you do just a get by ID or key, that's a much cheaper operation. And then, of course, the most important thing really is using Memcache as much as you possibly can, because Memcache is free and it's fast. So it'll both reduce your data store costs and it'll increase the throughput of your application. It'll reduce the latency on the application. So right here we're going to run through a little sample here. One of the things we had in our application was each user has a bunch of settings. Now, you could stick these things probably in a property on the user thing, but you could actually have a couple hundred in our application. So what we did is we had a separate DB model for the user settings, which is, if you can imagine, this is the simplest approach to it. So you have a user, which ties it back to the particular user for that property. You have a name and value, and it's nice and easy. You just call, you just filter it on the name, you get that, and then you return that to the user. All very simple. Under the new model, then, this is going to start something that's going to start costing you, and it's going to be quite slow as well, because a data store fetch is usually about, on a good day with the master-slave data store, it's probably about 50 milliseconds, whereas Memcache call is probably about 2 milliseconds. So we're using a fetch. We're not using Memcache, and actually, the way this thing is actually done, we could end up with two settings having the same name for the same user if the multi-threaded nature of the thing kind of slips up on us. So so that's kind of the basic idea of how that works, the simple thing. Now, this is what you have to get in order to reduce your costs. So you can get an idea of, something, this is probably pretty readable to people, have a bit of familiarity with code. This starts getting a bit mental. So, but it's something you have to do. So what we're doing essentially is we've changed our user setting now. So instead of storing the name and the user inside as a property of the user settings, we're storing it directly within the key, which means that once we have the user and the name, we can retrieve it directly by the key. So most things in App Engine, if you just create them without thinking too much about them, you'll get an ID auto-allocated by Google. And the IDs are unique to that entity for that parent. But you can actually give it anything you want, any text string, I think up to about 60 characters. And so what we've done is we've actually gone ahead, you can see the very top one right there. It's just going to be our user key underscore our name. And that just generates a certain amount of uniqueness. And it also means that if we accidentally try and create one of the same ones, we'll get an exception on that, and we'll have to try and handle that. So, so you can see down there when we call the get setting, we get the key name out of the system. We have a memcache key for that because memcache is shared globally across all the systems. We try and get the thing out of memcache first of all. If we fail to get it out of memcache, then we have to go ahead down to the data store. But instead of doing a fetch based upon the on a gql query with the name, we just can get it directly off the data store, get by key name. And that's one of the small memory operations. Whereas if you look on the previous one here on line number 4, that's actually one of the expensive operations. So the expensive operations, I think, are 7 times the price. It's kind of a pity you constantly have to think about price when you're writing code, but I guess that's life. And then when we do get it out of the data store, we can put it back into memcache. I think we're missing a friend there, aren't we? And put it back into memcache. So next time you come around, if it's been fairly recently, the memcache hasn't been flushed, we'll be able to get it directly out of memcache and save ourselves a lot of bother. So, easy stuff. So one of the questions that constantly comes up, and if you read the forum at all, people are saying, App Engine is screwed, this is the end of it and stuff like that, and then the sky's falling. And a lot of that is sort of to try and tweak Google, changing the pricing model mostly. And there's some people who genuinely can't stomach it, especially for some of the small things where people are just doing it as a hobby. So is it still worth it? Yes, it's absolutely still worth it. For us, at least, we've got 4,000 teachers signing to Aladdin every morning, and just trying to be able to do that off of taking attendance is a very expensive operation. So for us, we get a huge spike in the morning, and then everything dies down again. And trying to do something like that, either on bare metal or something like Amazon, and trying to scale that up and trying to handle all that and patching all that stuff. I don't know if you guys have ever had a job patching, servers and load balancers and managing certificates between, reverse proxies and all that rubbish. It's nasty. It's a nasty job, and you could end up spending a lot of money on somebody to do that for you full time. So really, it's a matter of the total cost of ownership of App Engine. All that stuff just goes away. You know that Google's patching their servers. You know that they're managing the security far better than you could ever do that, no matter how good you think you are. Google's got somebody out there who's probably smarter than you managing your security. And then, of course, in terms of the resiliency, you have the App Engine across multiple data centers. So I think there was actually one of the incidences earlier on in the year. There was actually a fire in one of the galleys of one of the data centers, and they had to do an emergency failover, and the whole thing was down for I think 15 minutes. So if you're running your own web servers and you have a fire in your data center, you're going to be down for a lot more than 15 minutes. I can promise you that. That just makes everything much better. So yeah, it's still worth it even at a higher cost. Like I said, there are cheaper options. Probably some of us out there have maybe a Black Knight, Minimus account or something like that. That costs $50 a year, and it's got a whole heap of bandwidth, and it's great for running your little website, So $50 a year, I probably run about 7 or 8 websites for various friends and charities off that. So you really can't beat that kind of price. But when you're talking about something serious, where the data is important, where you want the scalability, where you want the resiliency, you just can't be beat. The big thing that people complained about App Engine right from the start, and it's still a valid complaint, is the fact that you get lock-in. So you're writing to Google's API, and there's a few things out there like Typhoon AE, and there's another one that try to be open source ones. And I've looked over them, and I don't have the patience to try and deal with that kind of stuff. So you are locked into Google. And the fact that Google did jam up the prices 4 times, people start to say, so, there is a concern over that. But again, it's just a matter of balancing what you need versus, what you're prepared to put up with. For me, at least, I can spend my days, working with customers, writing code, and not have to worry about the website being up, not have to worry about, do I have the latest patch, doing a Sony. I mean, you guys are familiar with the Sony breach, That was entirely because they didn't patch their servers. So, if a company, the size of Sony, admittedly, they're the devil incarnate, But other than that, they're you expect them to at least get their servers patched, but it's a hard thing to do, and it's a hard thing to get the management approval to do things like that. So yeah, it's definitely worth it for us. Your mileage may vary, and the best thing, of course, is the fact that Google is moving the thing out of preview. So that means they're actually committing it to long term. There's stuff in the Google terms for App Engine. How am I doing for time? There's stuff in the Google App Engine for saying that they have, if they are going to deprecate App Engine, they're not going to do a wave and sort of pull it in a couple of months. They have a 3-year runway on that. But there's all sorts of exceptions for that, saying, basically if it's costing us more than it is to run, we can get out of it. So the fact that it's coming out of preview really does sort of indicate there's a long-term future for the thing. That's it. Any questions? No, I wasn't actually. No, I mean, it is, there's a few things we'd certainly like to see change, There's some things that have been on deck in terms of features, like SSL and custom domains and a few other things like that, and migrating from the master slave to the HR data store. This is all kind of independent stuff to the actual cost increases, So the costs are manageable for us, So it does hurt a bit, having your costs go up 4 times. But, you got to be able to manage that, so it works. Yeah. There's a whole bunch of actually blogs out there and stuff like that. If you go into App Engine or you go to the Reddit forum on App Engine, you can see a bunch of people that sort of say, there's a lot of people seem to be running a lot of Android or iPhone apps with App Engine as their backend, and they actually discuss their costs as to what it is, But it's really a matter of how efficiently can you write your code. If you can memcache it, if you can actually use Google as a CDN, if you can actually make use of that, and put your expiries tags on your HTML pages, that can be very, very cheap and very efficient. But if you go in there, with a big chainsaw, and you're not really sure what you're doing, it can get yourself in trouble. So. Yeah. Yeah, but the most important thing is a startup. The most valuable thing you have as a startup is your time. You can't put a price on that, right? As a startup, you probably put 0 on your time. But, longer term, you actually want to start getting paid, And that just means you've got to innovate as quickly as possible, and you've got to make sure you have the best possible service. So, I mean, it's not gonna kill you. If you're actually paying $9 a month, which is kind of the minimum spend if you go to a billable account, you're going to get a lot of mileage out of that. You're going to get a lot of instance hours. No, it's definitely not going to be that. $9 a month is going to buy you a lot. You can work out the number of instances you'll get out of that, especially on the prepaid plan. I mean, there were people on the forum complaining about $9 a month for their, applications that were making money. And I'm like, that's like, if I'm talking about a €50 a year, plan from Black Knight, that's only twice the price, So it's like, it's not outrageous for what you get, So it's my advice to a startup, unless you need to specifically do something that App Engine doesn't do, around, DNS settings or security or something like that, And even then, you can farm bits of your application off to Amazon, using web requests. So, I'm going to sound like a bit like a shill, but it's for us, it's absolutely paid off without a doubt. So, that's about it.
The question is it worth it? Another question is how to compare with
The problem is it's apples to oranges. It really is, I mean, people have, put graphs up, saying an Amazon EC2 small instance costs, this many, euro per day, and you get this amount out of it. I mean, there's no question you can find it cheaper, I mean, but some Django hosting guys, I've looked into some of those guys. There's some outfit out of Germany who does it pretty darn cheap, But I mean, if you've had to, deal with these people, when it hits the fan, they're not going to be there for you, And some of them may be, and they'll do their best, and they're honest people. But, the biggest problem with App Engine is the fact that if you've already committed code to another provider, it's a big effort to switch over. And if you are stuck, if you have committed code to App Engine, you're stuck there again, You're really not going to be able to move out. So, you know, it's you know, how much risk are you willing to take? And there is risk, you know, so.
You mentioned logging there, like if you write it in Django, it's less logging.
No, that's a complete fallacy. Basically what happens is, you know, Django has, you know, their templating system. And then underneath that, they have all of their, you know, active record equivalent stuff. All of that's pretty much gone. There are other things. There's Django non-rel, which wasn't actually released when we started, you know, and things like that, that, you know, probably can get you out of a hole. I have no familiarity with that. And I don't really tend to trust those kind of things. You know, I've used Hibernate in the previous existence, and it's like, things like ORMs and things that smells like an ORM kind of freaks me out. So, but, you know, do your own thing, so. Yeah. So. Anything else? Yeah. I'm not actually going to go into that. I could say that it's reasonable for what we're doing right here. It was probably, again, it depends on what day you're looking at. If you're looking at on a non-school day when the application isn't very busy, it's about 100 times. On days when it is busy, it's probably about 4 times, maybe a little better than that. And we've managed to bring some of that down too. And we haven't actually, on our application, we haven't actually run through these things yet. We haven't actually tweaked that ourselves because we don't have to go that extreme yet. So if we do that, you know, I'm just afraid of the customers, you know, what impact it'll be on them. It's only at this time of year, you know, we're in pretty much a heavy sales cycle, so we don't want to be disturbing it. So, any other questions?
Have you seen any tools to do code analysis?
Yeah, there's a fantastic thing called AppStats, which Guido actually wrote for App Engine, and if you're not using that, you definitely need to be looking into it because it'll basically break down the whole thing in a nice little waterfall as to what's costing you time.
But that's for running app on Drug.
You mean like a static analysis kind of thing? No, I think that you'd be wishful thinking, you know? You're putting some consultant out of business. Anything else? Yeah. Yeah, I mean, the memcache is volatile. So, you know, if you do have instances where your server goes down or Google has to shift you over maybe, you know, somewhere else, it can go away. In our experience, when the site is busy, we usually get, you know, 15, 20 minutes out of it before it gets shuffled off to something else. We don't put a lot of big things onto memcache, you know, something like a setting is fairly small. So, you know, it's yeah, you know, I wouldn't actually. Beg pardon? It's completely unpredictable. It's both based upon the load on the particular server you're on. You know, so if a lot of other people are using memcache, you may get squeezed out. I think you get a guaranteed minimum. It's also based on the number of instances you're running. So there's just, you know, there's no real prediction for it. But, you know, it definitely improves things. There's no question about it. So, yeah. Like on my laptop here, I have probably a 15, 20 megabyte sample database that's kind of been running for probably about a year and a half now, and so there's a lot of stuff in there that you know has sort of random customer data. But like even today, you know, we deployed a fix last night, and one customer had a particular piece of data that was in a certain way, and you know they couldn't do something. So, you know, it's very, very hard, you know, to get your data onto a particular test case. You know, you can unit test it up the yin-yang, you know, but you can't with App Engine. You know, I mean, just in terms of the cost. You know, you can download the whole thing. I don't think there's any tools to actually import that into the local data store. There probably is. Somebody's probably written some tool. But, you know, I mean, you know, if you're talking about, you know, a 25 gigabyte database, you know, so I mean, you know, that's just you know, that's what you can do in App Engine, however, and in fact, the best thing to do is you have versioning. So whenever we deploy a new version up to App Engine, we use a different version. And those versions actually share the same data store. So you can actually run your tests on non-live system, but the live data store. You know, so once you've actually, you know, confirmed that you're not actually deleting data, you know, you're not doing anything stupid like that. You know, you have to fly by the seat of your pants. You know, so There's just, that's just the nature of live data, unfortunately. Customers do things that we never, ever anticipated. Anything else? Yeah. We get a lot of questions about data protection. So the official story from Google on data protection is the fact that the data for App Engine is stored in North America. And so as a result of that, Google is unequivocally covered under Safe Harbor. So there's no issue with that. It would be great if Google actually had an EU data center purely for performance reasons. Because you do take, even with Google's, CDN, you do take probably at 150, 200 milliseconds on the round trip to California. So it'd be nice if we had a European data center just for performance reasons. But no, there's no issue with security in terms of that. Everything is SSL. Our application actually uses HSTS. I don't know if you're familiar with that. It's actually built. Our URL is actually built into Google Chrome. You get the advantages of things like Speedy, which is Google's sort of next version of HTTP. Perhaps. I mean, Google has things like, like SAS 90, and they have the ISO things, which, if you know the business at all, aren't, they're not really, but they're nice. And the thing I will say is, you've got to, when you're choosing a hosting provider, look at the other data they're storing, Is your data the most secure data they're storing? In which case you probably have a problem, So, if you were storing something very valuable out in another data center from some other provider, if it's, confidential information, What do you mean? Yeah. Yeah, well, I don't think it's HIPAA compliant. So, but yeah, I mean, even Microsoft has admitted, that fact that even with the data they store in their EU data centers, it's still subject to things like the Patriot Act and stuff like that. And if you look at the even inter-EU bank transfers that were cleared through the SWIFT system were actually being intercepted by the NSA. So it's like you just can't get away from it. So probably maybe you don't want to use it if you're running a madrasa in Pakistan or something like that. But other than that, you're probably okay. So, how many instances? We usually peak at about 25. So, and then probably overnight we actually have a couple of hours maybe where there's actually zero. Not extensively. We run them on an as-needed basis. So the great thing about this thing is the fact that it spins down pretty quickly. So, anything else? All right, we will leave it there then. Thanks very much.
Sit down there, guys. Right, we'll start again then. So Pavel's going to talk about a project that a couple of them, or was it three on the team? 2 or 3? 4. I don't remember 4. We're working on at the HTML5 weekend, which is focused on WebSockets for whiteboard applications. So,
hello. Can you hear me? Okay. Hello. Okay, I must keep it. So my name is Pavel. As Sean said, I made a project on HTML5 hackathon with 3 other guys. So I will give a short talk about this project. So the basic idea was to make a real-time multi-user whiteboard using Canvas and WebSockets. It's you can check the source code. It's on GitHub. The hackathon was over a month ago in AOL Dublin. and those are authors of this project. So as I said, these are technologies we use in this project. So basically the first idea was to grab a HTML5 boilerplate as a good starter for the whole project. It gives you a nice template and a whole structure for HTML5 based projects. And then we put a canvas to be able to draw in browser, and we do some logic using WebSockets. And as you see in the first version, so actually in the hackathon, we used as a server-side project JWebSocket. We end up with using it at hackathon because there was no much time to change the other technology, but we wanted to change because the JWebSocket was very immature project. It was very unstable. It went down during a presentation. So after hackathon, I've done some programming and changed the server side into Tornado, which is Socket.io implementation on top of Tornado. And Tornado is a Python server framework owned by Facebook from recent time. Okay, maybe I'll just show you how the project works. So the site is very simple and it's full of bugs. So, but as you can see, I'm drawing on the one side and it appears immediately on the left side. And that's it. There are some minor features like changing color. Nothing sophisticated. Actually, maybe some hint for you. Like there is no function to clear canvas, and the hack for it is just to make a small resize of the canvas, and then it goes clear. Yeah. You can see this. These are the logs from the server, from the Tornado. Okay, let's go further with presentation. Okay. Okay, so what are WebSockets? So this is the one of the parts of HTML5 standard. Actually, doing this presentation, I found out that not all WebSockets is part of HTML5 because W3C is standardized only the API of WebSockets, but the protocol itself is developed by other organizations. So only API is a part of HTML5. So WebSockets is a is the ability to create full duplex channel from JavaScript inside a web browser. It's not just a simple sockets as you can know from other languages. It's created in this way to make to be able to use them in the existing infrastructure. So somewhere there are HTTP proxies, and WebSockets needs to work through that. So trying to set up WebSocket channel, the first things that protocol do is HTTP handshake. So browser send this HTTP request to the server side, and if the server side responds to the browser that it's able to talk through WebSockets, the protocol upgrades the transport to TCP protocol. So the advantage of WebSockets is that once the channel is set up, there is no this HTTP headers overhead. So some people made some calculations how many bandwidth you can save using WebSockets comparing to Ajax, and the numbers are amazing, like 1,000 times data less goes through the wire when you use WebSockets comparing to Ajax or long polling. What about browser supports? It's very new part of standard. Supports is, I can say, too poor to use it in production for now, but it improves very quickly. For example, in mobile browsers, Safari supports it, so you can use it in iPhone, iPad. In Android devices, like I think stock browser on Honeycomb supports it. On smartphones, it's only Opera, and it's not supports by default. You have to go to deep configuration of the browser and switch WebSockets on. This is like a chart which can show you, how much you can save using WebSockets. So especially when you have a project in big scale, so there are thousands requests per second. So the difference is amazing. Okay, Socket.io. This is actually quite a nice project which deal with the lack of support from the browsers. Basically, it's a wrapper API over WebSockets. So the thing it does is that whenever it finds out that current browser does support WebSockets, it uses this. But when we use, for example, IE, which does not support WebSockets, it goes through other technologies, like you can see in here, like Flash sockets, Ajax long polling, and try to use them. So the API is very similar to the WebSocket API. You use it in very similar way, but you don't have to, you can be sure that older browsers will be able to use your applications as well. I can show you some example of code of those APIs. Okay, so this is how the pure WebSocket API looks like. As you can see, it's very easy to use. You just create WebSocket object and register some events appearing using the channel. The Socket.io API. To use this, you have to only import library Socket.io, and sorry for that. So as you can see, API for Socket.io is very similar to WebSocket. When I was working on the version 2 of this hackathon project, it took me maybe 15 minutes to switch from WebSockets to Socket.io. So it's very straightforward. Okay, very nice project based on those technologies and some others like Redis for data storage and so on. Is SocketStream. I don't know if anyone of you heard about it. It's like a full stack web framework based on the single page paradigm. So probably you can't use this when you want to create a REST service. But it's very, very nice when you want to have a service which stream real-time data to many clients, like stock market prices or currency prices. I'm not here to talk about this project because I'm not an expert and I didn't do anything in it. But I've seen some presentation and it's really amazing. So I recommend to try this out. As a demo of what can you do with this, I can show you a small game. It's a real-time game, multiplayer, so you can join me now if you want to race with me. The whole game is written in JavaScript. I think animations are in CSS3 transitions. This is very nice, of course, full of bugs because the guy, I think, made it in 1 weekend. So it's very nice. And the last thing I want to tell you is that as Brendan Wise asked me to mention about it, Owen Barnes is coming to Dublin. He is the lead developer of this framework, and he will have a workshop next Saturday in AOL Dublin office. It's open for everyone, so if you are interested in this project, feel free to come and participate in it. This is the agenda of this workshop. You can see how what technologies are used in this framework. Those are very nice technologies, and most of them are worth to know even separately. So, I think Sean will put a link to this event on the Google group. At least Brendan Wise told me that.
Brendan already sent the email to
Okay. Yeah, I didn't see that. That's why I'm asking. So
if anybody wants more information on this,
yeah. So that's it about my presentation. So if there are some questions.
So are there interoperability issues between different browsers? You mentioned that the protocol wasn't standardized by those 3C.
Actually, I didn't have any issues after I switched to Socket.io. Like even if I used pure WebSockets in Chrome, in Firefox, I didn't have any issues. I tried also mobile browsers, but as I mentioned, only Opera supports it for now. So.
You tried to do this, if I remember, very peer-to-peer.
Yeah. So WebSocket standard doesn't take into consideration creating, or how to say that, or listening on the socket inside the browser. So you have to have server side. I think I saw some blog posts that was saying that Opera is able to open a WebSocket inside the browser. So you probably using Opera, you should be able to have peer-to-peer, browser-to-browser communication. But I think that Opera has different kind of plugins API. Like when you want to create a plugin for Opera, you create it in HTML, JavaScript. I'm not sure. I haven't played with that, but this is the thing you should try if you want to do that. So.
successfully in mobile devices once the API gets it up there. Is there any native support for handling things like connection losses or change of network, so change of IP, that sort of thing? Does it gracefully fail or does it ungracefully fail?
Actually, I'm not sure. I think that protocol must somehow deal with it. Like, you have to have specialized server-side server to can use WebSockets, but I don't know how it deals with failures. Okay, so thanks for attention.
Okay. Okay, so I'm going to give a short talk on a confession almost on some of the stuff that we were doing in the HTML5 event in August. So we had a team of 3 people, myself and Mark, who's smiling down there at the back. I think a bit. You'll be out. And I can't remember. Do you remember the name of the guy who was on the team with us? I can't remember his name. He wasn't there for so long. So we're working on a project we were trying to exercise some of the new file support in HTML5. So in particular the file system API, and we were I had some harebrained scheme that it might be able to tie it into some of the Google storage stuff that is relatively new. So Lou's objective was to learn something about working with HTML5 files in HTML5. So try to do some of the Google Storage API and file system APIs. So the natural thing to do was to see if we could get some Dropboxy-like thing to work in a browser. However, that was a little bit naive in terms of we thought we could do a lot more in the browser than we actually could. So we encountered a couple of problems. So problems talking to the Google domain from content server from the non-Google domain was a problem. And the file system API was only relevant for a single domain. So what we mean by that was that you can't, if you set up a file system locally for a given web app, it's only available to that web app. So something working on another domain can't access that. So that meant that the idea of accessing files over multiple web apps through the file system API was not workable. So after we had looked at it a little bit for the first few hours of the event, we said, okay, that original idea is not going to work. So we had a little regroup. We said, what are we going to do here? So Mark came up with the idea, in fairness to him, of let's try and do some simple group file sharing application, let's say focused on music. There was some stuff about playing out audio files through the browser, which we did, which I'm not going to talk about here because there wasn't really anything very new in that. So the idea then was to have a server side which was talking to Google Storage, use the file system API and the client side to store content accessed from the server and try to sync those up a bit. And then we had the music components to the story. So that was what we tried to do. Didn't get a whole lot of that done, but we did learn some things, and I suppose that's the point of this. Hopefully we can share some of this stuff, which you might find interesting. So talking to Google Storage, some of you might have been here for the talk that Martin Omander gave a couple of months ago on Google Storage. He gave some very nice little demos of what it could do. We found when we tried to use it, there's a whole lot more complexity in it than was evident from the demos that he gave. There's quite a lot of authentication stuff that goes on in particular. So when you're setting up your app on Google Storage, you have to go through the APIs console and set up authorizations to access Google Storage. So you do the standard OAuth stuff, creating a client ID secret and specify a callback. You have to give the users Google Storage. You have to give access to the user's Google Storage account via OAuth. So what this meant then is what we did is just a link on the page which links out to Google and performs the OAuth and then comes back to our app via callback. You specify client ID, the redirect where it comes back to, and the permission that the app requires in that link. What we were doing was we wanted to have full control in Google Storage. So what that means is that you have read and write access, but you also have access to modify the access control lists. Other permissions are read-only and read-write. So that's the Google API console for anybody who hasn't seen it. So you can set up multiple client IDs for testing, which is something that I've found in other OAuth stuff that I was doing was a bit of a problem, but Google has, I think, done a good job on that. Complications with access. One of the things that we hadn't really thought about was permitting multiple users to use the system required multiple Google Storage users, but Google Storage is designed to support both Google Storage users and non-Google Storage users. So the idea is that you can, using Google Storage, set up a bucket and share it with people who are not registered on the system. However, this is complicated enough to differentiate between the two of them. One uses an OAuth flow for guys who are already registered in Google Storage, and one uses a cookie-based mechanism, and you use a sandbox at google.com/storage link, which you share with people who you've added to the access control list. So we were looking at the sharing mechanisms that it provides, and it took us a while to get our head around it, and we decided just to get a single user working on the system, because that looked like it was too much of a too difficult for us to get working. So we were using the Boto library. We had problems getting the Boto library working with Google Storage. Mark had a bit of experience with using that in S3, and we did manage to get it working on S3. So that's what we did on the Google Storage side. On the file system API side, we learned a bit about the file system API. It supports storage locally for web apps, cannot be accessed by a different domain, which I was mentioned earlier. It's more sophisticated than the key-based local storage mechanism. It can support hierarchies of files of different types. There's various properties associated with each of the files. The file system itself can have one of two types, temporary or persistent. Temporary means that the browser can remove content from the file system as necessary. So the idea there would obviously be if the browser was consuming too many of the resources on the system, it would start to delete files from the file system. Persistent is where the browser essentially makes a contract with the web app that says it'll only remove content from the file system on approval of either the user or the app. So the initialization of the file system, you say the type, the size, and then there's a couple of callbacks, one of which is optional. The type is that temporary or persistent. The size is how much space you want it to consume on the local storage. Okay, there's an error handler. There's a file error type that HTML5 defines for different types of file errors that your app should probably deal with. File entry and directory entry. These are different types. The directory entry supports navigation through directories, so you can list all of the entities that are in a directory. The file entry object supports read, write, create, delete operations, etc. Yeah, there's some JavaScript code which shows how to set up a file system, and what we were doing there was we had this. This is a laser pointer. Okay, so what's going on here is that we set up the file system. In this case, we set up a persistent file system, which is 5 by 1024 by 2024. So that's specified in bytes. So it's that's 5 megabytes of storage available on the local file system. This is the callback here on success. In this particular system, in the code that we wrote here, all that we wanted to do was to iterate through the root directory, and then when we had generated all the files in the root directory, we call this list results function. File system, when we get this success callback here, the file system has been obtained from the browser. File system.root is defined as obviously the root of the file system. For some reason which is not entirely clear to me, reading a directory in the file system API is not guaranteed to return all the directory entries in the file system. So the standard way to ask the file system API for all the entries in the directory is to call read entries multiple times, and when we get back no results, then we know that we've got all the entries from the directory. So here we're just adding them to the entries array, and then when we get back no results, we call this list results method. And then, okay, that's just adding the elements to something in the DOM. The only thing that's probably worth pointing out there is we can ask, these are file entry types, and we can ask them specifically, is it a directory or not? And then if it was, we added a different image to the DOM. One thing that causes a bit of problem was that Chrome wouldn't provide the file system API. We spent an hour or two trying to really figure out what was going wrong here. So there was examples provided on the web, and they just weren't doing what we had expected them to do. So the solution was to run Chrome with the parameter unlimited quota for files. So that was something that was not obvious to us. So conclusions and observations, we felt the file system API was still very raw in terms of if you have to run Chrome with flags to use it. I've tried it in the Chrome browser and it's not available in the iPhone browser. What we also learned is that Google Storage does have a lot of complexity behind it, and most of that then is really related to access control. I suppose a thought that would occur to me on that is that, you know, people are saying, is it going to do a lot of damage to Dropbox? I guess it's probably a little bit more focused at enterprisey kind of stuff than maybe Dropbox is. And then the last point is probably need a little bit more clarity on a project when doing a hackathon, because time is quite limited. So that's all that we found, I think. So has anybody got any points, questions, issues? Sergio?
So which problems did you run into when you proposed
It was largely around authentication. We couldn't figure out how to use it to get access to the buckets that we had set up. So Mark had done a bit of stuff before on manipulating and navigating files on S3. So all that stuff was stuff that we were familiarity with, but it was just the initialization of it that we couldn't do.
Well, the documentation is a bit spread out. I know this because I worked on something similar recently.
So file system.root in that JavaScript that I showed, no, that's the root of the file system that the browser gives you. So the browser gives you a file system which is specific to that domain, and you can do the web app can do whatever it wants within that file system. So obviously a browser can have multiple file system.roots for every web app that it's running using the file system API. No more questions? Okay, so Pavel mentioned, I guess we wrap up then. Pavel mentioned the AOL event. I think that's on this weekend, Pavel, isn't that right? Yeah, it's on this Saturday. So if anybody's interested in that Node, JS, CoffeeScript, etc. stuff. If I remember rightly, it's comprised of a few talks, and then in the afternoon, it's a bit of a roll up your sleeves and yeah, bring a laptop. Yeah. So there are instructions or there's information on it on the GTUG mailing list. Another point is about recording these sessions. So I think I put out on the mailing list that we are recording the sessions. This one is being recorded as well. The last one, Jean sent on the video. I haven't sent it out to the list as yet. We'll do that straight after, and then this one will be. Where are they being stored, Jean? On Google Storage, I guess. Yeah, okay. And it's okay to leave them there, I guess. So it'll just be a link to that content then. So we'll circulate that after the event. And so if anybody's interested, we'll probably go down to the schoolhouse for a pint now. And the next session is the last Tuesday of October. I don't know what date that is, but we have a guy lined up to give a talk on Go at the moment, and there probably will be one or two other things appearing between now and then. So I guess we leave it there. Thank you very much.